gonna try and make sure the slides are up. Yes, so just a quick introduction about the organization and where I'm from. I'm from the Government Technology Agency in Singapore. It's a relatively new agency. There's been a bit of kind of reorganization of, and I won't go into those details, but effectively we are the government technology arm. So we support various government ministries in the use of technology in order to achieve what we call our Smart Nation vision. So I'm part of the Government Digital Services team, and there's a kind of 20-man team that looks at data science in government, helping agencies make decisions and make policies using data rather than using a gut feel. It's really about data-driven policy rather than policy-driven data, as they say sometimes. So maybe just a quick introduction about my interest in this area. So I started off in my earlier life as an economist by training. Got back to government and was really passionate about trying to fit linear lines into kind of 100 data points. And it got kind of a bit challenging to do that in government until I ended up doing transport regulation. So I used to be a bus and train regulator. And then I discovered that using big data and using the tap in and tap out data, you could do a much better job about monitoring the state of public transport in Singapore. And this was a time in Singapore where buses were hugely crowded, a lot of unhappy customers. And we were able finally to use data to get a good picture about how to improve public transport for citizens. And that was really what got me excited about data science and the application of data science. So this talk is really an applied talk, and I'm just going to share with you some of our experiences using data in public policy. And maybe this is my perspective, and I really enjoyed the first two talks, learned so much from them. And I think Sean was talking about what data science means, and this is in a way what it means to us. When you talk to a lot of corporations, when you talk to a lot of government agencies, the IT teams and the operations and strategy teams are two separate teams, right? And you don't speak the same language. The IT teams just maintain the database, they make sure the engineering works, but what to do with the data to make it valuable to the business, whether it's sales, whether it's strategy, whether it's operations, most of the time they don't really know. And the people in policy and operations, they do slides, they do papers, but numbers, some of them they can do Excel, but when you're talking about gigabyte, terabyte level data, they're not really sure kind of what to do with it. And I feel that the area of data science is really that intersection, being able to get these teams to talk to each other and use advanced computational techniques, can be simple descriptive techniques, can be machine learning, can be graph, algorithms, but really devoted towards the use case. So we're not building systems, we're not doing engineering systems unless there is a very clear use case. And Occam's razor will use the simplest technology or algorithms that are necessary to do the work. And this work is inherently multidisciplinary. I'll come to kind of the kind of skill sets we see in our team and that we feel are effective, but that's just our perspective. So the other problem is that data science means different things to different customers and different users. Even within the government, we've got many different users. We've got people supporting the ministers and the permanent secretaries making decisions. They're more strategy type people. You've got people running operations, trying to make sure that the public housing works well, dealing with feedback, dealing with other forms of applications, operations. And then you have people who build applications for government agencies. And so we found that the deliverable in each case tends to be quite different. So if you're somebody reviewing a policy, welfare policy, or optimizing a certain decision, doing a planning decision, you don't need an ongoing data system, right? What you need is some insight from, in order to do a policy review, but you may need to crunch a huge amount of data to inform that insight. So that's kind of the first bucket that we see, that a lot of the agencies want some strategy analysis, but driven by data, not driven by just pretty pictures. So that's insights. The second thing is a lot of agencies maintain operations, so they want to know the state of the operations. What is the state of my public transport network? Right? How crowded is this bus at that bus stop? What is the state of feedback? What is the citizens complaining about? And for this, they need an application. They need a dashboard, a tool, ongoing service. And a lot of these times, it doesn't need to be completed a complicated machine learning. Most corporations and agencies just don't have a good state of their operations. And a simple dashboard, whether you want to build a web application in D3 or you just want to use Tableau, can be incredibly powerful. And then the third thing are applications, and this is where you need data pipelines, machine learning pipelines in the background in order to recommend a more customized solution or to use graph analytics for fraud detection. But these are really where the machine learning is working in the background to deliver a better experience or better decision making. So we've seen many different clients within government with different needs. We see different skill sets. We've got social scientists, we've got behavioral economists, we've got designers who want to do information design, more researchy type algorithms and machine learning people. We tell them, forget about research, right? No more publishing papers. Two of them are in NIPS in Barcelona now because we want to keep them current to figure out what's going on in deep learning, but they're never going to publish papers anymore. That's what we tell them, right? But others are just the software engineers writing production code and applications. So for the rest of the presentation, I just want to give you a flavor of some of the things we've been working on and some of the ideas, and really to see if there's happy to have continued conversations later on. So there's one little piece of work that we did in the last month, which was pretty interesting, which is where data scientists were able to help a train problem on our circle line. So Singapore has about many metro and MRT lines, and there was a single line which had a number of issues that began in August. So what happened was that the trains were braking all the time, and the reason for the trains that were braking was because there was signal interference. And this was going on from August, September, intermittently, and the train engineers and the metro and then the regulator could not find out what was the cause of this signal interference. What our team did was we had three data scientists who went in and were able to kind of investigate using data. They had no train engineering expertise, and we were able to pinpoint the source of this interference to one single train. So this was a case of data scientists being able to help teams that have been staring this problem for 2 or 3 months and who weren't able to identify the situation. So this was caused huge disruption. My team members, they were late for about 2 hours on 3 days in a week. So on a Saturday, we got a call to say, can your data scientists help? And I asked the volunteers, and everyone was like, yes, it's a national issue, and let's see how we can help. So I want to talk you through how we use small data and data visualization to really pinpoint the problem. Now, in this particular case, the incident seemed pretty random, right? That was the reason why the engineers couldn't really locate the problem. Was it a software update? Was it a particular train? Was it a particular station? And they couldn't figure out what the problem was. What they did was they gave us, when we came in, a set of data which was indicated when the signals happened. So you see in the data set, it's not a particularly huge data set. It includes the date, the time, the train number. From the train number, you can infer which batch of trains it came from, the make of the trains, and where the instance happened. And I'm just going to take you to, you can follow me on our blog, which is blog.data.gov.sg, and we've got like a little notebook, it's on Medium, and you click the first one. There's a little kind of a Jupyter notebook where you can kind of walk through the code that the team wrote on the day itself. So essentially the team came in on a Saturday morning, and by Saturday evening they were able to, in a couple of hours, they were able to isolate the cause of this that had befuddled about 30 or 40 train engineers for the last 3 months. And it wasn't machine learning, it wasn't very complicated analysis. So we got the data, as you know, wrangling, lots of data wrangling, getting the sequence of the trains in order. And if you do simple, just descriptive analysis, it looks pretty much random. So this is a plot by time. And you can see, obviously, there are more incidents at about 8 o'clock in the morning and in the evening, but that just corresponds to the peak period. So there are more trains running, so it's not surprising that you have more incidents. We then mapped it by location. So are there more incidents happening in the vicinity of certain train stations? There seem to be more on the western side of the line rather than the eastern side of the line. But again, nothing particularly surprising. We then looked at train IDs, and the train IDs that are sequenced from 1 to, I think, 30, and the first batch of trains, were there a difference between the first batch of trains and the last batch of trains? Not really. So again, it looked pretty much random. I will do a footnote here that the train that we eventually identified was PB46, and that's the train here, and it had 4 incidents of signal breakdowns. But this ultimately was the train that was causing the problems. But if you just look at it cursorily, you couldn't actually tell. What we then did was to try and think about different ways of visualizing the data. And some of you who do transportation visualizations will be familiar with what's called a Merry chart or Merry diagram. And what this does is that it looks at the train station plots, the train stations on one axis, and the time of travel on the other axis. So what this line is it shows the movement of the train based on the location of the train from one end to the other end, The train turns around at the terminal, it comes around the other end, and this is basically a plot of train movements. So inspired by this, we decided to do our own Mary chart with the same axes, but except in this time we wanted to plot the incidents. So it's not the location of the trains, but the location of the incidents. So this is some of the code to write all the order the train locations, and this was what the plot looked like. So if you plot the incidents where there was signal loss, this is what it looks like. And again, at cursory glance, it kind of looks pretty random. But our data scientists were staring at the problem, and then they decided to encode the train direction. So in every station, there are tracks in different directions. So the arrows represent whether it's on the inner track or the outer track. And then suddenly, if you stare at it hard enough, you begin to see certain patterns when you zoom in. And it was noticed that there was a sequence of incidents. So these are incidents on different trains, but they all happen to be in kind of a line and a sequence, as if the events are propagating across the train network in time and in space on different trains. This is a visual inspection, and they wrote an algorithm to see how many trains happen in the sequence. But to cut a long story short, they were able to realize that there was this kind of zigzag pattern in the incidents. Now the question then is, what would cause a zigzag pattern in these incidents? These are all different trains. It's not like it's one train moving in that particular direction. And someone said, what happens if it's a train in the opposite direction that isn't breaking down, but for some reason is causing signal interference and failures on these trains? So what happens if there's a train on the opposite track that's in a way a rogue train that's killing trains on the other side of the track? If you've watched Death Note, you get the idea, right? Somebody walks by and then people around him kind of die. So that was the hypothesis, and they brought this to a committee at 4 o'clock on a Saturday afternoon. They went down to the train control center on a Sunday to watch this train, and essentially they also got the train timetables. So they found that all these incidents only happened when PB46 was in service. And when the train service was being maintained or repaired, incidents went away. And this was repeated on multiple days. So it was a really compelling case. You've got a lot of train engineers who were initially very skeptical, but we were able to isolate all these cases. And 80% of these incidents were attributable to the movements of one train, and that was PB46. So by Monday morning, they had made the decision to remove the train from service, and all the incidents stopped. So this was a case where a use of simple data visualization was able to kind of isolate a problem that train engineers couldn't spot in a long time. The reason was because I think the fact that we brought fresh eyes, that we weren't experts who were biased in certain views, I think allowed us to take a much more agnostic view towards data. So this was a little small victory for data scientists. It was a pretty fun example where we were able to kind of help ourselves, because a lot of our data scientists were very frustrated with coming late to work, and that was a little example of how small data and just the use of data visualizations actually helped save Green a national problem. So that was one fun thing we did that had some sort of public impact. Some other work we've been working on, there was a brilliant talk earlier about the use of NLU, natural language understanding. It's a big problem in government agencies because we've got lots of feedback from different agencies, and unlike tabular data where it's easy to analyze the data, it's very difficult to get a handle on textual data. So simple topic modeling, LDA, another algorithm that we tried is something called structural topic modeling. We're exploring word-to-vec applications. But really it's about the use case. And we started off by trying to model what people are saying in Parliament. So this is the public information. You run a number of topic modeling algorithms, and it emerges with different clusters. And we looked at what the first Parliament speeches were about in 1965, and what a more recent Parliament in Singapore, what they're talking about. And you can again do a topic map of how all these are related, and the issues are completely different, right? So when Singapore first gained independence, it was about rural development, urban development, reading of bills. And then nowadays it's more about societal issues and public feedback and perceptions. So we did this almost as a form of validation. One of the problems with topic modeling and unsupervised methods is how do you validate this? But psychologically, this convinced a lot of our users that actually these topic models had value, that they were able to pick up fairly subtle clusters in the data. We then went on to use it for a number of feedback applications. So one agency is the Housing Development Board. So in Singapore, 80% of people live in public housing. Public housing is a big deal for young people who want to get married, because you can't get married unless you have a house and you can move out and live with your parents. So we analyzed about 100 billion emails, put them into topic clusters, and they've got a CRM system. The challenge was that a lot of the taxonomy in the CRM system became outdated. So a large proportion of their cases were just tagged as others, because it didn't fit nicely into a category. So using topic modeling, we were able to identify underlying themes in the data, and we found out that early key collection, or key collection, was a big deal. So it turns out that when you apply for a flat, or an appointment to apply for a flat, when you go to the counter and give your details, they give you a fixed date. And it turns out after we did the topic modeling, we found out that a lot of people wanted to change their date. A lot of times they changed it earlier because they were in a hurry. And after we did these clusters, we found that actually 1/3 of their feedback was about this issue. And because we were able to quantify this, senior management in the organization decided to change the whole business process, where you would allow the citizen to really pick the date rather than it being assigned automatically. Now, the point here is this: they had anecdotal feedback that this was a concern, but being able to find the topic clusters and put a number to it to tell them that 1/3 of your cases are really about this issue really kind of gave them the impetus and the momentum for senior management to look at the data and to change the business process. So they revamped their website and their online system, and this is again another example of how using some of these techniques can be particularly useful to help deal with issues from citizens and to be more responsive government. So that was a bit about incident response, visualization, and then a bit about using topic modeling to help citizen engagement. There's another little project that we're doing in transportation, which I call Beeline. You can go to beeline.sg and look it up. But the problem is really one of urban transportation. And in a city like Singapore, the question is, how do I get people to their destination in the shortest amount of time, and obviously in a cost-efficient way? So I can have mass public transport like trains, but you always have to transfer, and it's not for everyone. You have taxis and Ubers on one hand, but it's not very environmentally sustainable because it's one car to one vehicle. So can we do better? So this heat map is a heat map using anonymized EZ-Link data. So when you go on public transport, you tap in and you tap out. And so using these records, it's a couple of 100 million records, we're able to calculate the time it takes in the public transport system in the morning. So if you live in the central part of Singapore, you've got a pretty good commute, you're blue. If you live further out, you're probably going to be red. What's interesting though is that it's discontinuous. So if you live in this part of Singapore close to the MRT line, then you're blue, but if you're a little bit further away, you've probably got to do a bus transfer, and your commute is much less direct. And so our problem statement was, can I reduce the journey time for the system as a whole? So we looked at this data on the Beeline platform. We crowdsourced data about where people want to travel from and travel to. And this is a web visualization showing the results of an algorithm that we ran. And the optimization problem is this: we want to minimize journey time, subject to the constraint that we can still at least fill a bus of 20 people. Because I can minimize journey time by giving everyone a taxi, but if there's not enough density, then it doesn't make sense, right? So we said, can we get a better journey time? We call the Google Maps API to make a comparison, while at least having 30 people within the 15-minute window. And so the algorithm spits out recommendations for direct bus routes. So what we built is, using the analytics, we have a recommendation of what direct bus routes we can run on these 20-seater minibuses. And we've got an app that allows bus companies to list their bus routes using this crowdsourced data, and allows people to pay using Stripe, and allows them to track their buses. So you have a code that you show on the ticket, and you can board the bus. We are also given analytics, so the driver has an app, so you can track the driver, and because you can track the driver, you can give notifications when the bus doesn't turn up, and you can run all sorts of analytics in real time to better manage the punctuality of the buses. And really what it is a means to manage more dynamic and evolutionary bus system. So when I was in the Land Transport Authority, I realized that bus routes are fixed, and they really don't have to be fixed. They can be much more dynamic, just like a shared taxi, and this is an attempt to do some of that. And we released the API documentation is open if you go to api.beeline.sg, because we want to be able to integrate with various other platforms and various other services, but we see it as a way to use data to give better service, better transportation service to the commuters in Singapore. But you can actually take the idea of Beeline one step further. What's the difference between a shared taxi in an SUV and a small bus? Ultimately, a lot of transportation modes boil down to a few information or data characteristics. You want to know the consumer preference. Where is he starting from? Where is he going to? What time he wants to go? What's his price preference? What's the speed preference? You've got vehicle properties. You've got the number of seats on the vehicle. You've got the price that they're willing to bear. Some of you work in advertising, they're ad exchanges. Could we have a digital mobility exchange, which in a way is an open ledger that allows people to submit their preferences into an open ledger and allows different modes of transport to bid for these mechanisms, and therefore to allow a true marketplace, just like a stock market, but in mobility. And that's something which people call mobility as a service or digital exchange, and it's something we're thinking about as an extension to Beeline. So that's on the area of transportation. Another area that we're working on is really using urban data, and this is really on the big data. Nowadays we wait for statistical reports about the GDP and the state of the economy. But there are many other traces and signals of how well the economy is doing. So for example, it's a factory and there are fewer people going to work in the morning and tapping out on the buses. That probably means that the factory has laid off a couple of workers. If electricity consumption in that particular zone has dipped, it probably means that, after you adjust for seasonal factors of course, probably means that again they're not utilizing their factory lines to full scale. There's an API that in malls measures the number of parking lots or occupied parking lots in some of the malls. They've got sensors that measure this, and there's an API for that. That gives you an indication of how popular the malls are at different points in time. So you have an idea about how active these malls are. So one idea we've been thinking about is can we actually use non-traditional big data, real-time indicators to get a better sense of the pulse of the economy? So GDP is a very aggregate statistic. It usually lags by about 3 or 6 months. Can we predict the economy better using non-traditional big data? So that's another idea that we've been working with. We also run the open data site. The blog I showed you just now is a blog for the open data site, but we're really trying to bring open data to the layperson. So using data visualizations, using open source technology of course, but also encouraging government agencies to open up more APIs so that they can programmatically query these APIs. Just the final slide, we've launched something which we call the Smart Nation Fellowship. It allows technologists and researchers to come and work with us for 3 to 6 months. Our most recent fellow was a gentleman by the name of Arun Kishore. He works at YouTube out in the Bay Area. But we're open to all forms of technologists who want to do work for the public good, come and hang out with us, work on some hard problems. So Arun was able to develop a framework using Polymer to allow data sets to be overlaid and compared on top of one another. He also worked on some forecasting model for pulse of the economy, doing some of the predictive analytics around that. So we're open to new, we just want to kind of learn from the best out there. So if you know people or you're keen, please do apply at fellowships.data.gov.sg. And that's pretty much what I have to talk about. My experience with data science is that it needs to be very practical. You need to see about how you can deliver value to users. And in our case, it's about seeing how we can make the lives of the public servants a lot better. But also at the end of the day, it's the end goal of making the citizen experience a lot better using data. And that's what the team is super passionate about. Right, so thanks very much, and happy to take any questions.
I'm Hafiz from Axiata. When we were describing your team, right? So you were mentioning that one of the team members are basically behavioral economists. So I'm curious as to how you make use of a person of that expertise, and how does a behavioral economist make use of data science to design actions that can nudge people in different behaviors. Yeah. Thanks.
Daniel, who's a behavioral, he's an economist more generally, and his expertise is in randomized control trials. So the holy grail for any evidence making is a randomized control trial, not using big data because you can never prove causation. So what we found is a lot of the times we do some descriptive data analysis, scatter plots analysis, we might build a model, but sometimes just building a predictive model using machine learning is not the right approach. Sometimes you need to run an A/B test or randomized control trial. And that's where the kind of behavioral economists are quite useful. We find that a lot of the challenge is really defining the problem statement. So I go to an agency and I ask them, what's your problem statement? What's your hypothesis? What's your problem statement? Their reply usually is, my problem is my CEO wants me to do more big data and more analytics. Right, no. Okay, let's work that through, right? Okay, so what metrics, what problems? Is it an important problem? What are you going to do once I do this analysis? Are you going to then pull the train out of service so that people don't get affected? Or are you just going to show a nice visualization to your boss and it looks good? I mean, so a lot of the conversation is around what problem we can solve with the data you have, what problem we can't solve, and what you're going to do with the problem, the so what question. And we find that the social scientists, the economists, are generally, there are many diverse skill sets in my team, are pretty good at that. And then the hardcore kind of machine learning, graph algorithms, you leave it to the kind of PhDs and the computer scientists. And that's why I don't think data science is in a way, I mean, there's a lot of new developments in AI and deep learning, but I think the practical applications is about getting people with different skill sets who are curious and respectful of other disciplines to work together in a team. And I think that's the biggest challenge. And not expecting your data scientist to be a unicorn to do all different types of work. I define in my head 4 subspecies of data scientists. It's far too data scientist is a big ask. So you have to be quite specific about what you expect from different members of your team.
I'm from the Central Bank of Malaysia.
Okay.
Thank you for that very interesting sharing. Sure. I'm personally interested in trying to similarly embed more data-driven insights and decision-making in government generally, maybe the central bank specifically. So I have questions to do with, how do you start? What's the best way? Specifically, what do you buy, what do you build? Who do you hire, who do you partner, who do you train? Things like that. Basically, what should the priorities be and how should we approach it? Thanks.
So this team started about 2 years ago, and there were 5 of us. We weren't able to build any applications. So we don't start off by building Beeline or building data.gov. The software engineering tends to be quite manpower intensive. So we started off with a lot of the analytical questions for policy reviews. So I got, again, 1 economist, 1 PhD who understood machine learning. He also happened to be great with data visualizations. Okay? So in the early stages, I'm sorry, when you're presenting to a business audience, you need snazzy visualizations. You need people who can do stuff in D3. He was great with WebGL, and that is really kind of gives you really amazing visualizations. But you need to make sure that you have people who can define the problem well, and making sure that you deliver value to the user. The biggest problem, if you don't understand their domain, and this is where you need people from a strategy and policy background, is that you present all these charts that are not relevant to their use case, right? So we started off with kind of a small team, and it's really about bootstrapping. It's about demonstrating use cases. I time box our analytics projects because it's so open-ended, it can go forever. So I say our projects maximum 3 months. We'll do 1 phase. If that phase works, we might kill some lines of inquiry. We may open up new lines of inquiry, but everything is 3 months. So the first month and a half is probably just data wrangling and cleaning, processing. Most agencies don't have a data dictionary. They give you the data set, the schema. Like what does 2 mean? What does 1 mean? What does 0 mean? They don't really know, but if you talk to the sysadmin, he has it in his head somewhere. So that's the reality of data science a lot of the time. So it's really about bootstrapping, about demonstrating value. At first, working on proof of concepts, and then when you can, generalizing. So the topic modeling example that I gave you with public housing, we did that. We ran that in R, just used various standard LDA topic modeling techniques. And then now we're building it into a web app. It's a simple web app that runs the topic modeling algorithm in the background. You drag and drop your own data. It gives you a visualization that allows you to explore the data and label the data. So we start with individual use cases, and then where it makes sense to generalize, you build a system. Rather than the other way around, which is I want the big multi-year software engineering system, but then you use these systems and they deployed and then no one actually uses it because it's not particularly useful. So starting from the use case and making sure you're quite agile and quite iterative. I learned a lot from my software engineering team. which does agile processes. So working in kind of small sprints and always thinking about how to deliver value.
Philip Lester from Petronas. I was very curious about the comment you made when you were giving the example about the bus routes.
Yeah.
You said that bus routes are typically fixed, but you managed to turn it into flexible. Do you mean flexible in real time or flexible in terms of you adjust it?
Yeah. So that's a important question. So there are a couple of startups in Singapore now doing like Uber Pool, but in larger scale, right? So it's on demand in real time the route is formed. The problem there is a sparsity problem. You are trying to find 10 people. Uber Pool, you only share 2 people. Now I want to share 10, 15 people. What are the chances to have somebody that starts, ends at the same time, wants to travel at the same time, plus is on the app at the same time? Okay, the chances are very, very low. So unless you have huge amounts of density, you have a sparsity problem. So on the beeline concept, it is kind of, the routes are preformed. They can change month to month, but most of the time, if people want to go to work, they're going to the same workplace every day, right? So this particular use case is a bit far removed from taxis. Now, that's just because we don't have enough liquidity in the market, enough scale. But over time, you can imagine a mobility marketplace that allows all sorts of options. So the mobility as a service concept is really where you have different types of providers on the right-hand side, some of whom can be on-the-fly matching, some of whom can be slower evolutionary transport systems. But my point is this, that there are a lot of systems that we think as fixed systems, like your transport network, that with data, with mobile technology where you can notify, you can reach out to people, are much more evolutionary and much more adaptive than we think, right? And that's the starting point.
Okay, yeah. So I was really curious about the retiree group who may not have an app.
Yeah. Yeah. Conversational interfaces, so chatbots potentially could be one idea. You can do SMS. So once you go to backend systems, you can use SMS, you can use messaging. And again, one interesting thing is apparently Pokemon Go was responsible for a lot of retirees using mobile technology.
Okay.
So you never know. The new technology will come on and it will move along. But yeah.
Okay. Just a comment then. Thanks for sharing the stuff, especially the small sample analysis partner. In oil and gas, we have in excess of 100 data types with a lot of possible use cases that we can study your paper for. Thanks very much.
Yeah, thanks.
Thank you, sir, for such a very good and informative presentation. And I see a lot of old friends here. Okay, so very positive environment. I have 3 questions.
Okay.
Right.
We've got time.
The first question is, I find it very interesting on the topic mining.
Topic modeling, yeah.
Yeah, so basically you've created context of what politicians and policymakers should focus on. Yeah, so context, you are getting context. Also at the other spectrum, in the transportation analysis, it's more of like technical analysis, right? Have you seen a feedback loop from culmination of all technical analysis that creates a shift in policy making? That's the first question. The second question is, for the B line, do you see a potential for public services, for example, the disabled, the blind, and the ones which is, they need help, they need public help? And the third, as everyone already know, Singapore is the front runner for smart city. You guys are one of the leaders. Do you guys have any update on how it's going along, smart city for Singapore? And last but not least, I want to finish with a note. Actually, what the public transport analysis in public health is called technical analysis. A lot of analytics, you cannot find insight because a lot of analysis are tactical or strategic in nature. So technical analysis usually in public health, you can find the root cause. So it was a very good presentation. It's something that you guys can take a strong note on. Thank you.
I'm going to try and address some of the questions. I might need you to remind me. I'm going to move backwards. So on the Smart Nation, Smart Cities initiative, I think this is something that the Prime Minister himself has kind of set down about 2 years ago. It's an ongoing process. So the idea is to use technology and data to better deliver services. So there are many different components. Some of it is data science. Some of it is using digital technology to make it much easier for government agencies to share data. Some of it is building a wireless sensor network so we can harness IoT for various applications. So the Smart Nation is many kind of different moving parts. I won't do it justice by speaking about it here. But the important thing is that there's kind of a very strong mandate to use technology. Our Prime Minister codes, he wrote a Sudoku solver in C++. So he's the biggest technologist and geek out there. So that's very powerful because it means that it's a wake-up call to all government agencies. How are you using technology to improve your productivity, to deliver better services to citizens? So that's on kind of a Smart Nation. You had a question about technical analysis versus generating context. I haven't thought about that kind of too deeply, and I suppose one observation we have is that there are many different types of methods and techniques. You can use topic modeling, you can use randomized control trials, you can use machine learning, graph analysis, but we start first from the problem statement, right? And saying, here's the problem I need to solve, what data do I have, now what techniques do I need to wrangle the data and to process the data, enrich the data to make it useful to decision makers. And if it's a simple descriptive statistics or simple scatter plot, then we use that. We do see, I think the reality is this. So I spoke to someone I know from Facebook, and he says that whenever Mark Zuckerberg has a meeting, he's got all his dashboards, all the performance, all his websites, because it's software, right? It's all instrumented. So he knows the state of his organization. So weekly meetings, it's very quick. You come in, all those that met their targets, nothing to say. Those who haven't met the targets, they just do an explanation, they delve into the data, and they run analysis. So the whole organization is centered around data because data is available at fingertips. Data is inherently iterative. So you query, you respond, you query, response. Now, if I ask a question, a data question, it takes 2 weeks to get a reply versus 2 seconds because I can run a query, the rate of learning is several orders of magnitude different, right? So people say, oh, I just asked one query, it's between 2 hours and 2 minutes, no difference. It makes a huge difference because I'm not running one query. I need to run about 100 different queries so I learn and I iterate. So the question is, in policymaking, how do you allow the policymakers to get access to the right data with the right privacy protections, but also the techniques to wrangle the data? Sometimes a Tableau dashboard is good enough for operations people. Sometimes they have to write R code or Python code to look and pivot the data. So yeah, I think that's the second point. On Beeline, sorry, what was the question on Beeline again? Okay. We have had interest in that area. The issue again is of sparsity. Do you have enough people moving at the same point? It doesn't. It helps coordinate better people who are moving in the same direction. The question is will you have enough of these sort of cases happening at the same time? But over time, it's definitely a possibility. The current use cases, we see a lot of companies who have maybe run factories or run offices in more remote parts of Singapore. And a lot of people don't want to work there because they don't have good transportation options. So we're seeing a lot of organizations and companies come to us for that. I think we're out of time, so thank you very much and happy to chat later on.